Hi and welcome to this video on linear programming or linear optimization, maths made easy. Now linear optimization is where we get a linear function of a number of variables, and these can be maximized or minimized by taking various inequalities, graphing them and finding the best values under these conditions, under these inequalities. So we graph the inequalities or constraints, and then we form a walled off area using these inequalities, which is called a feasibility region. And then in the vertex method we test the corner points of this feasibility region, and we get our maximum and minimum values. Usually we're given some quantity to maximize, for example income, profit, or something like that. Okay, here we're just going to do a simple example of linear programming or linear optimization. Company selling soups, canned soup and packets of soup. So canned soup we're going to call C, packet of soup P. The daily sales of canned soup is less than 200. The combined sales of both are less than 250. And the sales of canned soup are always greater than of packet soup because canned soups taste better. So our constraints, canned soups are equal to or less than 200. That's the sales of canned soup. Sales of packet soups and canned soups are always less than 250 daily. And the sale of canned soup is always greater than the sale of packet soup. Now we turn each of these inequality into an equation by just replacing that inequality by an equal sign. So this first one becomes C equals 200, second one P plus C equals 250, and the last one C equals P. Then we draw a linear graph. So this line is C equals 200, this green line P plus C equals 250, and this one C equals P. So horizontal is C, vertical is P. Canned soup, packet soup. Now as you can see we've got two enclosed areas. So which ones do we choose? Now let's just go through this methodically. So we've got, first of all, on this one C equals less than 200. So we've got this C equals 200 line. So less than 200 is on this side of the line. So that's easy. Now we've just got to distinguish between these two areas. The best thing to do is choose a point, say on this side of the green line. So choose a point here and use that as a test point. And if you do that, you'll find that this side of the green line is where P plus C is less than 250. So we shade this side of the line, and where we've got this, where the two have a hatched shading, that's our feasibility region. So the feasibility region, if I highlight that, is this in the black lines, and we get the maximum and the minimum by testing these points, these vertices here, this 1, 2 and 3. Now we're given this as our objective function. This is called an objective function. So we're going to sell our canned soup at £2 and the packet soups at £1.50. So our income or our profit, which is what we're interested in, is 2C plus 1.5p, 2 from the £2, 1.5 from the £1.50. So profit, I haven't used P because we're using P here for the packet soup, so I'm just using income. So income is 2C plus 1.5p. Now we get the these X or CP points from here, XY or CP. So this is 125, 125, that vertex. This vertex is 250. This vertex is 200, 0. Put those values we found into the equation, into the objective one, and we get these values. And as you can see, the maximum is here at this point. So we get a maximum profit when we sell 200 cans and 50 packets of soup. So 200 cans, 50 packets of soup, and this is the vertex. Another way of doing this is using the gradient method, or sometimes called the ruler method, where we draw a line with this gradient. So it's the gradient we're interested in. So if we draw 2c plus 1.5p on this graph, it have a negative gradient like the green line, slightly less steep, and then what we do is we keep the gradient the same, move it up, and then it'll cross this point first, that line, and cross this point second. So the last vertex it crosses, that's the maximum value. And we'll go through that in the second example that we're going to go through. So in this second example, a little bit more complicated, there's a manufacturer and he's making two types of scooter, A and B. And these scooters, A and B, go through 3 departments where assembly takes place. A spends 2 hours in department 1, 1 hour in department 2, 6 hours in department 3. Scooter B spends 2 hours in department 1, 5 hours in department 2, and 2 hours in department 3. Now, because of the limited amount of workers, the departments are only available for 24 hours. Department 1. Department 2 is only available 44 hours in the week, and Department 3 is only available for 60 hours. There's a profit of £6 on A and £3 on scooter B. How many of each scooter should be made to maximize profit? So first of all, we want our constraints. We want to make our equations. Now, because the constraints are the hours available in each department, so this 24 hour, 44 and 60, and these hours are what A and B spend in those departments. That's going to be our constraints. So if we let x equal A and y equal B, so this is x, this is B. So if we look at this in department 1, we've got 2x plus 2y equals this 24. So 2x plus 2y is equal to or less than 24. And department B, 1x plus 5y equal to 44. So x plus 5y is less than or equal to 44. Department 3, A is x, so 6x plus 2y equals this 60, department 3. So 6x plus 2y equal to or less than 60. And our objective function from what they've told us about the profits, what did they tell us about the profit? Let's have a look. It's somewhere they do tell us. So the profit is, let's have a look. Profit is £6 on A and £3 on B. So our objective profit is 6x plus 3y. So now we write this as 2x plus 2y equals 24, 6 plus 5y equals 44, 6x plus 2y equals 60, our linear functions, and then graph those linear functions like we've done here. So how do we draw these lines in an exam? Quite quickly, I've done a video on that, drawing graphs or drawing straight lines, but an easy way to do it is just make the x or the y equals 0, and then we get 3x equals 30 if that equals 0. If we make the x equals 0, get y equals 30. So y 0, 30, and then this is the other point, then draw the straight line. And similarly here, x plus y equals 12, make that y equals 0, so x equals 12. And then make the thing here, so y equals 12. That's that blue. So these are the 3 constraints. Now, as you can see, we've got 2 enclosed areas by those 3 constraints. So we've got this one and this one. Best thing to do is choose a point. Say if we're not sure which area we want, choose a point here. And when you do that, you get, say here, choose 7 and 7. So if we choose that, put that into the equation. So 7 would be here 14. Plus 14 is equal to or less than 24. Clearly it isn't. It's more than that. 14 plus 14 is 28. So it's not this area we're interested in, it's this one here. Okay. So the vertex or the vertices that we're interested in, this one and this one. This we're going to use the ruler method or the gradient method. We use our objective function 6x plus 3y. So what we do here is we draw a line 6x plus 3y. How we can do that quickly in an exam, we just use a number, say a feasible number like 36. I've chosen that. Make 6x plus 3y equal 36. Make the y equals 0. Draw that point, 0 as y, so x equals 12. Make the x equals 0, 3y equals 36, so x equals 0, and our y value will be 36 divided by 3, which is 12, so it'll be here. Okay, so draw the line, and then put the edge of your ruler along the line, and keeping the gradient the same, move it up. Okay, like so. So we're passing this point, and then we're passing this vertex last. And like I said, the vertex that we pass last, that's the maximum point that we're interested in. So at this point here, that's the maximum, and that is actually the point where a equals 9 and b equals 3. So the maximum profit is when a equals 9 and b equals 3.